Hello, hello. Am I coming through? Yes. Fuego, fuego. This is a great song that I was listening to before the call started. I've been coding with LLMs and doing function calling. It's very fun. Very excited for Rayon Labs squad. I really want to make agents. But today, it's not about that. We have distributed and team and community and miners coming up on stage to talk about decentralized training. Huge deal. Long time coming. And there's no better person to usher this revolution and then distribute it himself. So let's get him up on stage. Why don't you come up on stage, Distributed? Who else do you want to come up with you?
Hi. Can we have Joel, Evan, and Joel and Evan if they want to come up? I don't want to bully. Oh yeah, oh cool. Joel and Evan.
Evan.
He's got a lightning in front of his name. Yeah.
Hello.
Hey guys.
Oh no. I have to seek through 94 usernames here. I don't know if I can do it. Do you see, can you head him up or can you just click?
Yeah, Evan. Or let me try to add him on the stage. Hold on. Okay, we'll get him later.
Which row is he in?
He's in the last row. He's the lion with
Oh, I see him. Great. Found him.
Yeah, and he needs to get rid of that lightning. I can never find him either. Cool.
All right. Joel, Evan, Distributed. Well, I won't try to steal your shine here. Let's just get into it. You have a presentation. You want to put it up?
Yes. Can you see my screen?
Yes, we can.
Okay. Hi. So, Templar decentralized training. We're not going to go into why we need it because I think we heard the voice note. But I just added this slide. Yeah. So the agenda is why. I wasn't going to talk about why before, but I saw something that really bugged me.
We can only see your Discord. Please, Discord, please. And also, I'm getting a bit of echo.
Hold on 1 second. Let's try that again.
Try that again. Not the echo. Oh no.
Hold on. Give me a second.
Oh my God, what happened? Don't worry, we cut out these first few moments of the presentations.
Is it better?
I think so, yeah.
Okay, cool. Yep. Let me share my screen. Can you see my screen?
Yeah, we can see some Ghibli there. And now we can see Templar, Holy Grail of Decentralized AI Training.
Okay, so I added a why. I don't think we needed a why because everyone saw listened to Const's voice note. But there's something that really bugged me all day. So we added a why. Then what we are doing, how we're doing it, lessons learned, and the road ahead. So why do we need decentralized training? It's because today the whole world thought this was cool. Sam Altman has violated someone's copyright, and we just vibe with it. And if that doesn't make you upset or at least strike a nerve, then I don't know. I don't know what to say to you. So we need the ability to build these models. Otherwise, people like Sam Altman can just do stuff like this. So, okay, so what is Templar? It's like, yes, we're doing decentralized trading, people are doing it, but it's good to, when we build Templar on BitTensor, what we realize is a collectively run intelligence market, that we can use the BitTensor as census mechanisms to produce models, and via detail it becomes a marketplace for incentivizing the creation of state-of-the-art foundation models. How? So in Templar, like with most subnets, it's you expose a problem, give it to miner, miner smashes it. So what is the problem we expose in Temper is that we, in an ideal world, and I say ideal world because things aren't perfect yet, miners contribute gradients. So in Templar, we each miner is training one global model. So the problem is, okay, how do we start from the validation system? How do we validate that the miners are behaving well? So in order to do this, we start on the journey of a miner getting a slice or a couple of pages from a data set. It has to be deterministically random. It has to be deterministic so that the validator knows which pages to validate on. Then as a miner, I will train on these pages. So within a certain, at Epoch, we call them block windows. The miner must train as hard as they can on these pages and put them into their storage, into their R2 bucket at the right time. Now, this is super critical because for things we'll see later, like you don't get that in decentralized trading, you don't get that much room for error. So my miners, bless them, they always go in and we slash too much. We slash a lot because the effects of fault, any kind of faults, be they crash fault or Byzantine, are so high. So I think Templar miners are like the hardest workers because honestly, they need to be perfect, 100% perfect for at least the entirety of the run. So you train on that slice, you run your forward pass, you do your best effort, you pass to the validator. Now, we're not going to go into the details of how the validator works. If anyone wants to do that in the follow-on, I'm more than happy to take them through it. But the validator must ensure that, okay, this slice, how good is it? Is it better than me lazily training on the slice? If it is, then has this miner really done enough? So the miner's job is to summon a gradient that beats the validator. And later, but that's what
distributed. Can you hear me?
We post weights. So that is Templar at a super high level.
Distributed. Can you hear me?
Yeah.
Let's pause here. You're going very fast. There's a lot. You skipped over the why. The why is huge here, and the Ghibli images. It's Ghibli, right?
Ghibli.
Yeah, and I think that it's inevitable that large language models are going to be ripping off artists. I think that one of the important things to note here is that if it's not possible for the community to train machine learning models that are at the scale of the frontier labs, there's simply no way for us to ensure that revenue is distributed out. So we're ripping off all of these artists. How can we make it so that thing is co-owned and dropped, and that value is dropped back into a large decentralized group of people? I think that's super important, and shouldn't be really skipped over too quickly. This problem of how can we combine resources from across the globe is one of the reasons why I got involved in BitTensor in the first place. We needed a way of combining computational power so that it didn't just become a purely centralized enterprise. So this art of combining resources is incredibly difficult, right? As you're going into in your descriptions of like how distributed, because you have to, it's hard to train a machine learning model just on your own data center. It's something else to try to train it across a large set of peers. It's a completely new level of complexity to try and train it across a distributed set of peers and then incentivize them when those peers are trying to destroy your model if it's in their self-interest, right? Like what's core about Templar is the fact that you have incentivization directly implemented into the training run. And I don't think anybody's ever done that before. But like, can I query you a little bit about the how? So going forward a couple slides, I think you cut out slightly, and so we can. I think this is really interesting. So, I've participated a little bit in the design here. So the miners are given a page to work on that is not known before the window begins, and there's a particular window of time, this number of blocks. I believe it's like 7 blocks, correct?
Yes, 7 blocks, 84 seconds.
And in that period of time, they know which window, which set of pages that they have to train on.
Yes.
And you use the block hash to determine that. So they don't know beforehand what those pages are, but everyone knows what pages they should be training on, and they take those pages off the data set and they produce a gradient. And
Mhm.
we use these R2 buckets. They have like a free ingress, correct? Or sorry, outgress?
Egress.
Egress, there you go. Pardon me. They have free egress, and the validators and miners are communicating through these R2 buckets. They upload these really large files basically to a high bandwidth location. The validators can download them, and they basically shit test that the miners have produced a gradient that reduces the loss on their sample of the data set. And so, like, how does the validator do that? Like, what's that process?
Oh God. Okay, so initially what we did was that in the latest iteration, what we did, we need to know how well you've done, but and we need to make sure you're training on the right pages. Initially, and very naively, we were just saying, okay, train on the right pages. So therefore, let's take your pages. We take a sample of your pages. You don't know which sample it's from. So we take we sample a small amount of your pages. Then we run a forward pass on it, measure the loss, then apply your gradients into our model, run another forward pass, and check the loss. Now, if you beat us, your score is by how much you perform better. But the miners taught us very, very quickly why that was suboptimal. And I'd rather go into it later when we talk about lessons learned.
Sure.
May I go on?
You may go on.
So lessons learned. So again, like, this is not like, we're training a live model. We are, it's running now. We can look at the run. It's, anyone can join. But I don't think I honestly believe that Templar is going to be the first to successfully train this and train the biggest. But for me, there was trying to build Templar is a crazy experience, both from an AI perspective, but also just from building anything permissionlessly. So the first lesson is it's insanely hard. So I spent most of my life in blockchains, and blockchains are hard. Permissionless trading is hard on steroids because we have BFT, we have businesses fault tolerance, that Bitcoin 51%. And everything else 67%. But with AI, it's almost like it's 5% or something. So this is why miners in Templar, like they were even bitching about it today, is you just have to be 100% perfect because there's no room for error. Now, we can look at other things, but as it is today, it's a very, very, very delicate process. And after 4 months of beating this and trying and running over 200 runs, sometimes 5 times a day, I think we're at the final stretch of getting this. Okay, cool. Now, secondly, is more of a personal one, is that, initially we tried to build a company and we tried to be perfect. Like, hey, this is Templar, blah, blah, blah. I'm the ex blockchain leader of the OTF, we're untouchable. And we failed. Like, it was every single day, it was crazy. Like, it wasn't going anywhere because we were trying to build a company. But it's like the problem we have with the problem I always find with blockchains. I think blockchains fail fundamentally because you swap out the government for new gods. You change your gods. So you cannot replace or fix the system you're trying to. You cannot become the system you're trying to fix. And becoming a company, that's what it does. So the biggest turnaround and when everything changed was one day Const posted on the channel that, hey, distributor is really struggling. Does anyone want to help him? And I told Const that, why the fuck are you making me look vulnerable? And I was upset for a couple of days, and that changed everything. That moment changed Templar into a frontier community. It's crazy because I'll tell people I've built this thing all on my own, but I haven't, and I could never have done it. Every single miner became a member of the frontier community. And all of a sudden they stopped being, let's fucking hack this guy. It's like, shit, this is us. Like, let's build this thing together. And that is the most I cannot explain how powerful that is. Next. Yep, miners. Like, these guys, amazing. We live and die by them, but they will also drive you insane. So, Const, if you don't mind, any miner that wants to come on stage, could you please invite them on stage?
Sure. Raise your hand if you're on stage. Noah's coming. Okay, great.
Hello.
Noah, get Daniel, get RL, and anyone else that wants to come, because I need some answers to some certain things, and it'll be good to get it'll be good to have the whole community judge them for their misgivings. So things that have made my life really interesting over the past 4 months are some of these exploits. So it'll be good to, if these are things that on Christmas Day, someone on this stage, someone on this stage kept me awake for 2 days with this exploit. So what was happening is that because in Templar we aggregate all the gradients, one of these guys figured out that if they send gradients with really large norms, they could capture the validator states. And on Christmas Day, I kid you not, I pushed this PR, and this guy's exploited me for 48 hours till I could just switch it off. So yeah, guys, congratulations. Sorry, I can't see the stage. Is Noah on stage?
I am.
He is on stage.
Yeah. Noah, do you know who did this?
No idea. But obviously it's someone on stage, so limited options here.
Cool. Another interesting thing was bucket copying. Now, bucket copying was why we had to improve our validation system. So it's very much like weight copying, because in Templar, miners need to share their, everyone needs to share their read keys. So anyone can read it. So very, very stupidly, we thought it was going to be cool that miners are just going to be busy solving their gradients. But it turns out it was crazy profitable to run a script, and just copy other people's gradients and throw them at the validator. So that was really fun. And I think everyone did this. Like, I think every single person, anyone that figured it out, did it. Then, more importantly, we had another problem called, I'll call free riding, and that was actually the beginning of slashing. So in Templar, we slash a lot. Like, miss a gradient, you're 1 millisecond late, you get slashed 50%. Yeah. Piss me off in the morning, you get slashed. But free riding was actually something that teaches you how, you must just always harden your validation system. So due to the temporal differences in the different stages of training, the first couple of people to get it validated, to get scored, they have the chance to reduce the loss a lot more and score a lot more, which we're still trying to fix, but we just haven't gotten there. But people found out that the validation was so slow that all they needed to do was, get 5 good scores and just switch off their machines. So this was really interesting. And when I discovered, I just went crazy and slashed people. I think I slashed 75% at one point in time. So yeah. Sorry.
something that I think is very interesting about this, and hopefully this point doesn't get missed, is that one of the reasons why BitTensor has been extremely successful in building functioning decentralized applications is that we build our subnets in Python, and we use tools like Watchtower, Docker Watchtower, that allows us to iterate on the protocol multiple times per day. And because of this, teams just go straight to production. When we were first looking at this idea, and I sort of gave part of the general design to Formalized, I very annoyingly thought, this will solve the problem, and this is done. And I sent it over to Formalized, and he was looking at it, and he put it out into the network. Imagine how far we've come from that naive first thoughts about how the incentivization could work. And there's just simply no way to test these systems other than in production. And this is why I think Templar is so far ahead of everybody else doing the same thing. You've now run 200 experiments and learned about, I mean, there's just 5 exploits here on the screen, but in reality, you've approached probably hundreds of different exploit angles and played whack-a-mole now for 3-4 months, until the point where now we really have thought about everything. And it's very difficult to come up with a strategy without testing it. And your miners basically are just red teaming you nonstop, right?
Yeah, but
this
but
is an incredibly yeah.
I really appreciate it if they stopped. Like, guys, we're friends now. Like, come on, like, just chill.
Another interesting point here is that one of the things that happens when we introduce token economics into each of the subnets is that the miners become shareholders, they become owners of the network. And as they become owners of the shared technology, that red teaming slows down a little bit because the individuals are incentivized to actually bolster the system and make it work because it's literally in their interest. It's a really interesting thing about open ownership and co-owned systems is that it stitches people's incentives together in a way that we didn't have pre-DTAO, right? Miners don't care if they break the subnet because they don't own any of the associated token on the subnet. But now that's changed, right? Now that everyone's up on stage. And I think it's really interesting that the way in which this generates a community of people that begin to work and improve the subnets collectively. So it's not just the owner at the center.
Precisely. I couldn't agree more. Like, detail just forges our fates together. And it's not everyone will get it. But as a subnet owner, you need to get it super quickly and also find a way to get your miners to get it. Because honestly, if they don't get it, you will die. Okay, cool. So the road ahead, so where are we going with this? Really short is we're 98% there on this, but we still have some burning questions. And so right now in Templar, we have we have probably about 200 GPUs running, but we only take top K because we can't explain some things like, what are the, like, there's some things we're still open research questions like, sometimes miners diverge from the global model, but why do they? Because if that happens within the top K sets, it would literally mess up the training. But we're okay now because we're training a small model and we don't actually need that many miners to train it. But as we scale to bigger models, we need to be able to leverage all 256 UIDs in a trusted manner. So that's something I think we saw very, very soon. Another one is a bit more, the next point is a bit more arcane, is that we need to be sure that we're not fully saturating the model at this token size, at this batch sizes. Because it could be that anything above 5 is a waste of like resources. This is important because it also measures that, okay, when we go to 70, how do we do it? What parameters do we need to control? Yeah. Oh,
But you guys can iterate fast. You've run 200 runs, right?
Yeah,
so
yeah.
you can chuck off a run. Like, what does it take to run a machine learning model on Templar right now? Like, just start a run.
What does it take? Sorry, does someone want to answer that? Because I just pushed the main, man.
Right, which is pretty incredible, right? Like, it doesn't take coordination from people. People are watching. They have automatic scripts. When things change, you push hyperparameters to GitHub, and boom, another run is off.
Pretty much.
So these optimizations are ways for you to use the compute more efficiently, more effectively. It seems like you've reached a point now where the run is stable enough that you're. Am I correct in saying that you're quite sure that it's more about optimization at this point and not so much about adversarial resistance?
100%. I think at this point we've pretty much covered it. Like we've pretty much covered that. We can produce reproducible. We can create reproducible loss curves over the 1.2 billion. So that's pretty interesting.
And what about speed here? Like, how fast are we moving? And what kind of optimizations are you thinking about in order to make this even faster? Because like inter-data center training is a hot topic right now. And can you talk about how we intend to match the efficiency of those data centers or other implementations of decentralized training?
Okay, so this is the interesting thing, but we still need to get like an evaluation study. Is that we're matching the original demo implementation, which, if that holds true, already beats Adam W. So Adam W is like SOTA for LLMs. Like people just chucking out Adam W because it can manage the memory concerns of an LLM, but we can already beat that. So it's getting to a point where we're not just doing this for the cause. Decentralized training is actually can actually beat centralized training pound for pound. So how do we get there? It's pretty interesting. There's different ways to do it, but one emergent thought is that you can run training and accumulation asynchronously. Because one of the problems we have, one of the things we're stuck with now, and I think Tulanan, the guy that runs Condenses, he pointed this out, is that there's a lot of waiting time. So you train the model, then you wait for sync. So eventually, Templar, we're going to be able to do that asynchronously, where you are gathering a step, so you are syncing maybe a step behind and training a step forward. We can do that now, but it looks it would quote unquote work, but it would really hurt convergence. So when we get that is such a massive boost. That means we're probably doing when we combine demo with that with a scheme like that, or with a scheme like that, we're probably doing a lot better than the centralized counterpart. So I'm pretty bullish about that future. And given the speed we're going at, that could be. I don't want to commit. So it's not just me anymore. I can't say I'll get that next week. But honestly, I wouldn't be surprised if it's ready in the next 2 weeks. Okay, so in the next 1 to 3, oh sorry, Const?
No, go for it.
Yeah, so in the next 1 to 3, and I say 1 to 3 because I have teammates now. Not everyone wants to work 20 hours a day, but I'm pretty bullish on them on the speed we can get this done. Is to train a really good 1.2 model. So the dream, the model is the product. Like that's what we're here to do. That's what we keep doing. That is our core mission. So soon, in a very in a very, very close future, Targon shoots 19, whatever else, they will run Templar 1.2b, they will run Templar 70b. So that's how we get there. So for us, understanding the arcane forces at the 1.2 are so important, because once we get 1.2, we will get 70 so much quicker, because we've perfected and mastered everything it took to build 1.2 at this scale. Then we've grown the team. We have a full research department. So as code monkeying all day, there's also people looking into the really studying the protocol and helping us create insights. So we hope to contribute to literature and beyond. Templar will be the best platform for training the world's largest models, and Valhalla. That's an inside Templar joke. Thank you. And yeah, I'll take questions now.
Wow. Let's see this run.
Okay, this run. Hold on. That's why I wanted all the miners on stage, so I could be sure that no one was hacking me right now. Okay, cool. Okay, so this is the current run. So there's two important views of the loss curve. There's the miner view, which is very noisy. So these are, oh no, there's a lot of them.
So so what we're looking at is, and this is really interesting, right? So no training run in the world has this amount of variance between its workers. That's really ugly. But basically, the validators, they're able to filter the gradients properly. So when you have a miner that's machine, they go off, it goes offline, they submit the wrong gradient, they're too slow. Basically, they got automatically filtered by the protocol, right? And they're also being incentivized to stay in line with the current run. Is that correct?
Yep.
And this is the level of chaos that you're dealing with, right? In a decentralized training run, you would expect this to occur. It's permissionless. You've no idea. There's been a number of other decentralized training runs, like News did one, Prime Intellect did one. It's all just compute providers, right? It's like them and Lambda Labs, or some personality on Twitter. Here, these are anonymous people trying to break Templar day in, day out. And so that's why you get all this chaos, because it is actually permissionless. And the permissionless aspect of the training run is important, because that's what actually makes it super competitive, right? People anywhere in the world can come in and try to contribute computation and minimize the loss according to the rules of the game. And if they can do that consistently and better over time, they win. It's not like, oh, I know you, why don't we train together with your laptop and my laptop? This is like out in the wild, right? So anyways, what we're looking at here is this is like the divergent losses of the miners are all screwing up. They're getting nans in their models. They're turning off, they're turning back on, they're on the wrong step. And then go back to the other screen. And so then this is basically like the filtered version of what's going on. This is the validator itself. This is the one that is coalescing the gradients produced by a variety of miners and bringing it together, correct?
Yep. Yeah.
And this is the most stable one you've had so
far. It's pretty much been like this for the past 4 runs. So yeah, it's pretty much, it works now.
Incredible.
It works now. The loss is going very soon. So I think from the next run, we'll be able to show live evals, see how the runs are in real time. We'll see how the runs are performing against industry established benchmarks. So it's pretty exciting for us.
And so if you're hearing from the miners on the stage, we got Daniel, we got Noah. All right, call bullshit on Formalize. Like, what's actually happening?
I'm coding on the next exploit right now, so ready for tomorrow.
No, but is it? Where is it actually directing you right now? Like, so as a miner, like, in what way are you scaling?
I think it's become very competitive lately. I really need to think about what I'm doing to earn any money. So, and it's not about finding bugs anymore, as it was, to be honest, a little bit in the beginning, which is great. Honestly, there's nothing to exploit that I found right now, so that's great.
So where's the alpha in mining on Templar? Noah? Like, what do you have to do? Just is it indeed? How can you train faster?
Um, I think I thought that training on more data would be the alpha, and I've been trying that a bit. I think other miners have too, but I haven't really been that successful with it, to be honest, which could be due to the fact that my miner model, is not entirely synced with the validator's model. So, like, the benefit I get from it, like a better gradient, drowns in the fact that my model is not the same as the validator, so to speak. But I think in the future, as we get more synced, like miners and validators, that could be alpha for sure.
Yeah, this is one of the
And
hardest.
that,
I know that
sorry?
Formalize has been working on this as like the main like issue in the network, is that when you have all these disparate miners trying out all sorts of different attack vectors at the same time, individually writing their own miner codes, no one is running the base miner, and everyone's communicating across the internet. How do you force the network to be in sync with itself?
Are you thinking model-wise now that like the weights are actually the same for everybody?
It was actually more of a validator side. Like, how does how are you crafting the validator to solve that very tricky problem?
It's to solve the problem. We needed to. It's more about enforcing. So what was happening, or what we think happens, is that sometimes you know, miners put their gradients in late. Validators don't always pull the same gradients. Miners have deleted some gradients before validators had time to pull it, or miners have deleted gradients before other miners have had time to pull it. So what we ended up having to do is to enforce T min and T max, which is, we enforce a time boundary. So that says, okay, the miners must put their buckets in by this time, and the gradients in the buckets by this time, and we will not allow any other gradients in. So we will slash you. So that kind of ensures that, one, all the miners are in sync, and two, all the validators are also in sync. So that kind of improves stuff. It's not perfect though, and what we find is that is that sometimes, even if it's just one. So let's say the global set that you're meant to be getting your gradients from is 15, and you miss just one, it can really balloon your loss. So it's understanding, okay, how can we force miners to always put their gradients in on time, and how do we ensure that we're also accumulating all the same gradients so that the global state is the same.
And so this is one of the interesting things about R2. Is it R2 buckets, right? This use of R2 buckets. People have made fun of us online for using them, but there's some really interesting primitives that you get out of using hosting services like R2 or S3. One of the best things is that there is consistent, globally verifiable timestamps on the objects. S3 actually acts like a blockchain. You can't change the timestamp of a file on R2 or S3. So you can actually say, hey, look, you need to update or upload this gradient, 10 seconds after the block shows up on BitTensor, which is a really interesting primitive. Like, I don't think that you can easily get that using any other technology. Time at a particular block, time when the gradient is uploaded. So you're enforcing that the miners submit their gradients within a very short period of time. So not only do you have that ability to force bandwidth, but you also have the ability to to guarantee that everybody can see the same information, right? Because if people were just gossiping, if I was sending my message to Noah, Noah's sending his message to you, and we're doing a full broadcast from every single peer to every other peer, you wouldn't know who is actually sending messages, right? As a validator, how do you check to see if Noah just chooses not to send a message to Daniel, right? You need this sort of like global pass-through method, and I wonder how other teams are solving this problem. But I think that using sort of R2 or S3 or R2 is essential for making this work across the internet in an incentivized way.
100% agree. And it was a bit of a pain initially because in the design, everyone wants to use like P2P. They want to use Eero. They want to do the cool stuff. But it becomes, when you do that, you need to choose the problem you're solving. We're not solving peer-to-peer communication. We're solving decentralized training.
Or incentivized.
So it's incentivized trading, sorry. So let's abstract anything that isn't 100% necessary for decentralized trading. And it just turns out that when you do that and you focus on what matters, that, okay, what do we need? We need timestamps. You kind of arrive at a solution that works for you.
Yeah, I believe the timestamp implementation is quite interesting. Using, like, other builders in the chat would be really interesting to know that every block on the BitTensor blockchain has a timestamp, which is verified and across the validator set on BitTensor. So you have a global clock that you can use. You can actually just query the blockchain and say, okay, well, what was the exact UTC time that this block occurred? And then you can go and check to see that the files were uploaded within a delta of that time. So all the miners know that this is how they're being checked, and they actually have to focus on that bandwidth. So it's just interesting that Noah was talking about this. And so, like, one of the things that you maybe would want to look at improving here, Formalized, is also allowing them to use different types of communication software. So, like, paying for more bandwidth on things like S3, moving from R2 to new types so they can pay for that bandwidth. And as soon as you go on.
So, Karen? No, you go on.
Well, as soon as you can frame something like a bandwidth problem underneath the incentives, the miners have reached the point where they need to optimize that, which it sounds like they have. All of a sudden, you've turned your network into an incentivized training and bandwidth network, not just an incentivized training network.
Yes, exactly, and that point you bring along about how we should give miners the opportunity to use better, use switch out different providers and to actually compete on that bandwidth level. It's something we don't expose yet because, again, it was just easier to force everyone to use R2. But sometimes R2 fucks up. Sometimes sometimes you get rate limited arbitrarily. Some miners are complaining that they couldn't upload gradients in time. So we should probably expose that. But we couldn't do it before the core was stable. So miners, thank you very much for keeping the core stable, and we will work on this.
Incredible. Distributed. So where should we go in this presentation? Should we just continue asking questions? Like, there's a lot of technical things to go over here.
Free flow. I'll take hold on. Let me switch off my screen. If I'm happy to answer questions or go whatever direction.
It's in the bottom there. Yeah. I mean, like, I'd like to maybe go back to the very beginning, and talk about why this is the holy grail in decentralized, well, just in AI, I think, right? We like, there was a YouTube video a long time ago, and it was Ilias Suskover speaking on stage with Sam Altman, and the interviewer, he says, like, do you think that there's going to be a challenge from open source AI? Now, back then, OpenAI was really just the only team, that was doing anything significant in the field. And then obviously we had DeepSeek come along, and people have been talking about how, open source AI is challenging OpenAI. I mean, of course, but DeepSeek itself is funded by the CCP, right? I don't really believe their numbers. I think that they are absolutely being backed. And they're a crack team and all that. It's amazing. But there's never been a competitor to these large frontier labs that was not CCP backed or 100 billion raise backed OpenAI. There's the argument that people make is there's just no way that open source contributors can ever coordinate the resources required to build something that is more significant than what these frontier labs can do, right? They're raising unbelievable amounts of money. And the reason is that, Subnet 9 is a good example, right? On Subnet 9, great subnet, but the compute is still disparate. Nobody is actually coordinating the training of the machine learning model together. It's you train your model, I train my model. So the winner there needs to be able to amass as much compute as the Communist Party of China, DeepSeek, or OpenAI, and it's simply impossible. And is it even the most efficient way for us to train these models? And so people have been talking a lot about, like, how do we coordinate and combine the computation from a variety of disparate individuals? Like, I have a GPU, you have a GPU, and all of us together have way more GPUs than any of these teams. But it's very difficult, right? So there's over the internet training itself, even in a non-adversarial environment, is just impossible. Well, no, it's not impossible because we're doing it right now, but it's very, 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 very freaking hard because all of the standard computational paradigms for training machine learning models are built around tightly packed data centers, right? All of the H200s are in the same data center. But even now, people are starting to question whether inside the frontier labs, they're beginning to question if that's even possible, right? Like Google has multiple data centers. And the GPUs are split across those data centers. How do they combine them? So we're moving towards decentralized training, even in the core enterprises. You guys are using incentivization, and this is what really, I think, separates you out from everyone else. Is that there is no team in the world that is using incentivization to train machine learning models. And that's where you go from, this is a cute open source project where a bunch of people that like each other get together and try to coordinate and work on something together. You get into Bitcoin mining style training of machine learning models. And if we get this right, we can unlock the ability to train not 10, 100, 70 billion parameter models, but like trillion parameter models across individuals across the internet. And I think that at a certain point, miners on Templar will actually be these frontier labs. And we also get to a point where then this becomes it becomes a shared resource where people can own that model because you can buy into it. You can contribute. You can own it. It's also transparent. Everyone can see it. There's nothing hidden. There's no concept of nefarious behind the scenes AI lab that controls the world. It's just something that everyone is working on together. And I think this is where, this is the why, right? And it's something that BitTensor has been focusing on for a very long time. So I'm a huge supporter of Templar, and there's no better front man than Distributed, who's gone ahead and given it all away to his mining community. So there's not really a person here. There's just the miners and contributors of Templar. So I'm really excited for them, but also anybody who goes in and tries to help out and contribute to this open source project. It's amazing. So anyways, Formalized, that's all I have to say. But is there any questions from the community here that people want to go up on stage and query, ask about the design? It's really quite interesting when you get into the nitty gritty. Like you just kind of skipped over the how aspect, Distributed, but like I'm sure you could talk at length.
Definitely. I just, wanted to get the miners on stage because I don't know, maybe I'm too absorbed in it for that that's a lot to do with the how. But happy to fill questions.
Easy trades up on the stage. Here we go. Hey, Easy.
Hey everyone. Yeah, great presentation, and Hans, I just wanted to say you're
We lost you there, Easy. I really need to know. What am I? He's gone. Censored. Yeah, he was gonna say something I didn't want to, so I just muted him. You're a CCP spy. Okay, well, we lost Easy. I could just go back on a rant. Look, I'm just gonna go stare at that training run and put myself to sleep tonight. It's so beautiful.
Honestly, like when we finally got it, so I wasn't sleeping because it wasn't working. Then it finally started working, and I still couldn't sleep because I was just watching it all night. It's absolutely crazy, man.
Great. Maybe we can get Joseph on the stage. Hey, Joseph. You're a supporter of this.
1, 2, 3.
We can hear you loud and clear.
Hello. Nice. Amazing work, Formalized. I mean, I think this is like super inspirational stuff. Like, it's pretty amazing that for the first time ever, there's a fully permissionless, incentivized group of people. We don't even know who they are. Like Cons was saying, like all around the world, sharing gradients and creating neural networks. This is like extremely profound stuff. I think it's probably lost on most people how profound this is. And like as a venture investor in another job I have is kind of pretty obvious. A lot of people already know this, but I don't know. There's probably over a dozen startups that have raised probably north of $250 million, I would say, maybe more. So like 250 to 300 million plus dollars to do exactly this, decentralized training. And it's all permissioned. There's like and I don't want to throw shade on any of these teams because they're all sort of like philosophically interested in the same outcomes, which I think is extremely admirable. But when you have people donating compute, or you have a group of companies that are sort of coordinating, and it's like, yeah, let's all pile in at the same time to sort of like put some nice metrics on the board. I think just like the early momentum behind Subnet 3 is spectacular and really awesome. Anyways, my question for Formalized is, what does the incentive mechanism look like as the miner community gets more complex, as these runs get bigger? What's your prediction on that? How do you sort of see that unfolding over the next couple quarters and maybe the next year or so?
That's a really hard question because I really don't like. It's impossible to guess what kind of to speculate on how the incentive mechanism would have to evolve to cater for because when we start building larger models, and we become more successful, the bounty for hacking the subnets becomes even larger. So what we found, like, okay, so let's take it back to the beginning. In the beginning, it was hard, but in a different way. But the attacks were very easy. There were mistakes I'd made in the code. They were, wrong assumptions I've made. But, oh no, the Christmas Day attack was complicated. But most of the exploits have been that way. But as the bounty gets even higher, as Templar continues to rise, then I really don't know. Because right now, most of the attacks are just bit tensor things or or they are like, they're not that complicated. But as we start to produce real models, there's two levels of adversarial resistance. What Templar has perfected now is what happens if send me the right gradients, send me the good gradients, take my loss down. But the next layer is, how do we make sure that we're building this really good 300 million, 500 million parameter model? How do we make sure that someone hasn't put a backdoor in it? I don't know the answer to it, but the incentive landscape would have to rise to whatever we're trying to achieve. And even when it does rise to that, someone is going to break it, and we need to fix it.
And in this come a lot of really interesting game theoretic outcomes. If it is possible to inject something into the model, there's also distributed consensus on what is injected into the model, right? You have a decentralized set of trainers. And so, it becomes a challenge to own the network in order to determine how that model is eventually trained. And what could be more important than the control over how AIs think in the future? And I think that that's far down the road. We're not there yet, but eventually that'll be something you'll need to think about in this network is, okay, right, who has control? And thankfully, from the ground up, it's built on BitTensor. And so there is distributed control and it's transparent control. And so people can buy into that control structure. They can negotiate the control of the AI through that control structure in a proof of stake manner. And like these things are like really long-term, sort of far out sci-fi aspects, but I think that it's important to focus on them now and see, where we might end up in the future.
Yeah, I totally agree with you, Const. Like, one thought, and this is just me kind of like copy pasting from open source land, which a lot of developers are familiar with. Like, you have these GitHub projects, and if you're a developer, you're sort of like committing code using Git, and there's sort of like snapshots of files and merging and pull requests and forking and all this kind of stuff. Like, we probably need at some level some similar versioning substrate, which obviously we get to some extent with the transactions that get persisted to the chain, and then validators that sort of like look at the sort of like synthesis of these gradients. But in the sense that, just to kind of build off of what Const was saying around, you have this like decentralized community that's incentivized to produce knowledge and intelligence using the machine learning process. Like, each one of those gradients would sort of represent a distinct kind of code commit to the sort of broader branch or tree. And I don't know, is weights and biases good enough for that? Do we need to invent new tooling? How do you think about this, Formalized?
Okay, so this is really interesting because anyone that's been on our subnet would know how much weights and biases I hate it. Like I hate it. But it does have this, like, if it's a question of, like, obviously it has to be open source. Like, it has to be built on open source, and an open source substrate. But the problem is sometimes the closed source one is just so easy to use. Like, why did I get stuck on 1DB? Because it does seem to give me all my login in one line, but it's suboptimal and it's expensive and it rate limits me arbitrarily. So when we build the systems, it's also important to build like systems that can't be captured, can't be controlled, that someone would arbitrarily rate limit you. So one of the things I like to see as we evolve is, so the storage subnets evolving on BitTensor. Can Templar, as opposed to using S3, can we use Storm? Can we use Hippias? Like, that'd be really interesting. Can we build 1DB on one of this? Like, so the more of that technology we can subsume and bring into BitTensor and into open source, the better it is for us.
what I want to see on this network, and I think we're getting there right now, distributed, is to the point where, we spoke to Noah about where he's trying to optimize in terms of bandwidth. But it would be incredible if the way in which the miners were scaling here was that they were figuring out more intelligent ways to produce the gradients as fast as possible, right? So the way that the Templar incentivization mechanism is set up, if I understand it correctly, is they need to produce a gradient which reduces the loss on the subsample of the data. And you could frame that incentive problem so that the miners have to produce, higher order gradients. They have to apply, KFAC or, higher level Jacobian gradients on their data sets to move faster. And so what could pop out of this incentive mechanism is not just the ability to train large models, but also to train them faster. And you can take all of the state of the art on producing gradients for a machine learning model and basically apply them directly into this market. You have a pure informational market at play here, right? How do you minorly change the weights of this machine learning model to maximize, or sorry, in this case, minimize the loss on a subsample of the data set. So you could imagine that this scales out to everyone gets H200s and everyone just applies, normal FSDP towards distributed training. But then after that, it's quite interesting. Like perhaps what happens is that miners figure out actual different learning algorithms, different ways of producing those gradients. And it would be really interesting to see how you can open up the validation system to allow for that. I can imagine that there will be massive data centers eventually working in this infrastructure. And at that point, it gets very, very, very interesting to see what kind of model we can train distributed.
Yeah, subnets go through, at least for my experience, a limited experience, subnets go through phases in what to compete on. When you first start up on almost every subnet, this is the mistake the subnet owner makes. The alpha isn't from doing the right thing. You spend ages trying to ensure that the only way to make money is doing the right thing. It is when you get there, that's when magic happens. So when I think Templar is at this point where, it's not a stupid bug. People need to optimize on bandwidth because miners would always do the least they need to do to make money. So as a subnet owner, you need to keep shrinking that space until the only way to make money is to do the work. Now, when they start doing the work, then they will innovate. So like what Noah is saying, optimize on bandwidth, it'll happen. Like I saw a loss today. Daniel posted a loss of 2.9 at like 600 steps. And that is something that we don't even see on testnet. So who knows what Daniel is doing? And who knows like those are the kind of optimization. So like take for example, is he projecting the gradients into lower rank? I don't know. But that really like today was like I saw that like, wow, when I'm running on testnet, that there's no adversary, I don't get that result. So Templar is moving to that stage where miners would always compete, but all the low-hanging fruit is gone. When all the 2.6, yeah. When all the low-hanging fruit is gone, then innovation happens. So I'm pretty excited to see that bit exposed.
Unreal. Well, perhaps we should end it there. Distributed. We've gone over a lot. I mean, gosh, we could talk for so long about like the philosophy behind running a subnet. And I just want to say kudos to Distributed for like being one of the first teams on BitTensor to really learn one of the most difficult but important lessons of open ownership systems. In my experience, having and continue to run a cryptocurrency in some sense, giving away power has been essential. to the success of BitTensor. I use tau stats every day. And that was created by Mog Machine, who wasn't part of the foundation. We didn't hire him. He's just somebody that is incredibly skilled and wanted to add value because he was aligned with BitTensor from an ownership perspective. All subnets on BitTensor should be pushing into that. And in order to make that really work for you, you need to give away power and you need to be humble. And I think there's no better person. There's nobody that expresses that or showcases that more than you, Distributed. You're also an incredible developer, but I think that you're also very humble and you've been able to build a fantastic community of like absolute geniuses. Like Noah, a bit of a backstory. Noah was actually hired and then fired by Distributed, and now he's one of the top miners. And you know, incredible thing about open ownership is you can't get rid of people, but that's actually for the better because they come in and show you how things are done, and that's because there is an absolute power wielded by the owner, right? And that's our, that's one of our superpowers. So, anyways, it's really awesome to see everybody up on stage. I thank you for coming here, Distributed. Really looking forward to seeing the end of this run, and maybe we'll have you back in a couple months when we're at the 70 billion. Thank you, Noah, Joel, Daniel, RL, Evan, Easy Trades, and Distribute yourself. Thanks, guys. Let's drop.